video, I'll be talking about differentiation, logarithmic differentiation, how to differentiate logarithmic. Please, what you help me do, like this video, make sure you share it. Thank you and God bless you. Okay, let's look at differentiation, logarithmic differentiation. Amen. Okay. Okay. Let's recall our elementary trig and linear algebra. You know very well that in log, if we want to talk about log A times B, one of the laws, this is the same thing as log A plus log B, true or false? Amen. Then 2 is log A all over log B is equals to, is the same thing as log A minus what? Log B. Amen. Okay. 3. If we have log A raised to the power of n, this is the same thing as n log A. True or false? Yeah, this is what we know in elementary trig and algebra. True or false? But in differentiation calculus, this is not where what we will use. What we will use is, you know, we are going to, instead of log, we are going to make use of in. Is that clear? But they are almost the same thing. That is what we'll be using here to differentiate a given function. Okay, let us consider the 3 laws. Note that if we have in A times B, this is the same thing as in A plus in B. Amen. Then also note that if we have in A all over B, this is the same thing as in A minus in B. Amen. Then this is the same thing as in A, if we have in A raised to the power n, this is the same thing as n in A. So take note of these laws whenever we are to use logarithmic to differentiate any given function. Amen. Okay. Let's look at one example. Example. Assuming you are asked to, we have if y is equals to in x, amen, then find dy all over the x. Okay, so let's write solution. We write solution, amen. Our y is equals to in x, amen. Okay, now we want to differentiate this function. If we are to differentiate in x, it implies that since we are differentiating with respect to what? X, this implies that our dy all over dx is equals to 1 all over x. This is the answer. Is that clear? Any question? Okay. Now, this is one example. Now, assuming we have here coefficient of x, that is, let's look at one more example. That is, assuming we have, if, this is another example, if y is equals to in 2x, then find dy all over the x. Amen? Okay. Let's write solution. For us to obtain dy all over the x, in 2x. Look at this. You discover that in the first example, we have only in x, but here we have in 2x. But if we are talking about objective question, the answer is going to be your dy all over dx is going to be 2 all over 2x. How? I know, Marians, you will ask how, but I'm going to show you, amen? I will take it step by step for you to understand, amen? Yes, this is the answer. How? That is what I want to look at, amen? Okay, so for you to differentiate in 2x, we are going to use what is called chain rule stroke substitution. So we'll write using chain rule stroke substitution. Using chain rule stroke substitution, amen? Okay? Okay. So now, what you need to do here, you are going to let u or any alphabet to be equals to 2x. Amen? Are you following? Okay. So what you need to do, you now say let either p or u equals to what? 2x. Then this implies that your y, you said let p equals to 2x, your y will now be in what? In p. Amen? True or false? So if you agree with me, it means you are going to differentiate this with respect to x. You will differentiate this with respect to what? P. So let's differentiate this idiot with respect to, amen, with respect to x. So here our dp all over dx is going to give us what? 2. True or false? Because if you differentiate 2x, it will going to give you, okay, for the sake of Malians, what we have here, we have invisible one here, 2 or false. Use it to multiply this, then multiply the constant here 2. 1 times 2 is 2. So this is how it will look like. 1 raised to the power of minus 1. Then our dp all over dx is going to give us 2x raised to the power what? 0. Note that anything raised to the power 0 is going to give you what? 1. Then 1 times 2 will give us what? Dp all over dx is going to give us what? 2. Is the reason why we obtain 2. Okay. Now, let us differentiate in p. Then go back to our previous example. You know that we differentiated in x to give us 1 over x. So if you differentiate in p, it will give you the same thing, but it will be 1 over p because the independent variable here is what? P. So our dy all over the p is going to give us 1 all over what? P. Amen? Okay. So if you agree with me, let's finish it here. If you agree with me, this implies that you don't need a prophet to tell you. You've gotten your chain rule. How? We have dy all over the b. We have the p all over the x. So our dy all over the x is equal to the product of these two. That is your chain rule. Amen? So what you need to do, you now write our dy all over the x is equal to either dp all over the x times dy all over dp, or whichever way, dy all over dp times anyone, because multiplication is what? Commutative. True or false? Okay? So now our dy all over the x is equal to, what is our dp all over the x? dp all over the x gives us what? 2. True or false? 2 dot, what is our dy all over the p is 1 all over p times 1 all over p. Amen? Then this is the same thing as 2 all over p. But note that your p is equal to 2x. True or false? Your p is equal to 2x. So therefore the final answer will now be our dy all over the x is equal to 2 all over what? 2x. So this is how to differentiate functions of this form. You see that we arrive at 2 all over 2x. Thank you and God bless you.